So you're playing a game, or at least trying to, but no matter how reactive you think you are, it always seems like you just missed, or really missed in that case. So what is it? Are you just bad at this? Or can you blame your keyboard, or more specifically, your switches? Hi, I'm Abby from Ratings.com, where we've just launched our first new product category in 2 years. Keyboard switches. Sure, it's not projectors or toasters, but there's a good reason. We wanted to see the impact that keyboard switches have on the latency of a keyboard. We updated our keyboard latency testing, and throughout that process, we realized that we weren't helping you all as much as we could have, since we were only purchasing one type of switch on each keyboard. The initial plan was to create a switch database to help us in the future, but I mean, if we're going to test a bunch of switches, why keep that internal? Thus, we set off to develop a whole test bench for keyboard switches. This is a part of a series on that test bench development. In this video, we'll dive into the research and development of our switch latency test and ultimately answer the question: how much of your gaming performance is you, and how much is your keyboard? Latency, in the most basic terms, is the delay from pressing a button to having that input appear on the screen. Most of the time, it's instantaneous and not perceptible to the human eye. Sometimes it's not just seen, but also felt by the user in the form of mostly frustration. The problem with measuring latency is that each part of a system introduces its own delay. And zooming in, mechanical keyboards are basically their own small-scale system comprising of two main components: the switch and the PCB. We are interested in both, of course, but PCB latency isn't as easy to isolate as switch latency, since we'd have to rip the whole keyboard apart just to get to the PCB. What we're interested in here is the overall time it takes for your finger to depress the switch and have it, well, switch. And it's expected that the latency of a switch depends heavily on the distance you have to move for it to reach that actuation point. This distance is called pre-travel distance. There's also the release, but we'll get into that later. By finding the switch latency, we can estimate the PCB latency and figure out how much the switch affects the overall latency of the keyboard. We measure switch latency using this little setup here, with a modified EpoMaker TH21 keypad attached to a microcontroller that reads and records the input data directly. We'll use the Kale Pro Purple and put it directly into the keypad socket. A solenoid strikes the top of the switch, meeting a piece of copper tape for an electrical contact point, so we see the moment the solenoid hits the key. This point of contact is our first measurement. Then, the switch actuates, giving us a second measurement point. We can then see the amount of time between the two to figure out the switch's latency. It's important to note that we're currently only using traditional mechanical switches since they have fixed contact points. Analog switches with dynamic actuation points aren't compatible with this testing method. Of course, just one press wouldn't give us any reliable data, so we take 200 samples. Then, to see how consistent the switches are, we use 5 switches of each type for a total of 1,000 data points per review. So, if you can imagine what our office sounded like, it was this. Over 100,000 times. 1,000 presses for 101 switches. Unsurprisingly, switches can have a lot of variance, which can be caused by a few factors, like manufacturing tolerances, quality control, or even the complexity of a switch's design. Looking at the Kale Pro Purple again, just one switch from the sample shows consistent latency results. Across all 5 samples, the margins are tight and the data looks pretty clean, meaning these are some consistent switches. The Glorious Panda switches, on the other hand, show a lot more variance. Each sample is different, and sure, while we are dealing with milliseconds here, even a minor delay can push your input into a later polling cycle on some keyboards. This could be the difference between a trap and a tarp. Consistency isn't just up to the switch, it can be our testing equipment too. For example, the heat of the solenoid can drastically vary results. As the solenoid heats up, it slows down its movement, causing the latency results to increase across runs. We control for it in the lab with a little fan, keeping the solenoid at a more constant temperature to keep the results consistent. The fan was a solid investment since we use it for all our keyboard and switch latency tests now. And while it does seem as though the solenoid is causing some issues, rest assured, it provides more consistent and comparable results than a human finger can achieve, with the bonus that it's faster. So far, we've only been looking at press latency. There's also release latency, which is the time it takes from the point of bottoming out the switch to the reset point. We can measure this between presses to speed up the testing time so we don't have to take another 1,000 measurements. From this testing, a few things stand out. Release latency is consistently higher than press latency, even if the distance to release the switch is shorter. Release latency is proportionally opposite to press latency. The faster the press, the slower the release, and vice versa. Analog switches and keyboards with a rapid trigger mode look to eliminate the added latency on the release by introducing a dynamic release point that moves as you move the key, meaning you can press the key repeatedly without having to wait for it to move back to a fixed reset point. Another observation was that release latency has more variance than press latency. What's up with that? Taking the keystrokes graph from the TTC Heart switch, we can see that the distance to press the switch is 2.0 millimeters, while the distance to release the switch is only 1.6 millimeters. Our theory is the solenoid. No, not the heat this time, but the speed. The solenoid relies on an electromagnet to press and register contact with the top of the switch, and it does this quickly. While the release on the switch relies on the spring inside the switch extending back out, the solenoid itself also has to retract the spring, which is slower than the press, resulting in a longer latency. We've mentioned that we expect switch latency to largely be a result of the switch's pre-travel distance, and with all our results, we can actually check this. There is a clear correlation between latency and pre-travel distance within a 0.3 millimeter tolerance. Looking at speed switches, for example, these are switches designed for low latency, and sure enough, they find themselves at the top of the pack. On average, these switches have a pre-travel distance of about 1.0 to 1.2 millimeters, making them ideal for quick actuation. Some other switches also score highly, and in most cases, they also have a low pre-travel distance. But they don't carry the speed moniker, so they aren't generally advertised for gaming, even if their geometry suits it well. There are a few outliers too, like the Gateron Zelio V2. Even though it has a high pre-travel distance, its latency is low. Even inside the switch, the contact points are identical to other Gateron switches we've tested, so it isn't totally clear what's at play here. The dynamic effects from the speed of measuring the latency likely have a role to play in why we see some outliers. For example, if the stem moves quickly, it could engage the contacts with enough force that they close before the stem moves into place. A few other factors could be the internal lubrication of the switch and the weight of the stem, but each of these factors would be too tedious to figure out on all 101 switches, and we don't expect either of these factors to have a substantial impact on latency. We were also interested in the correlation between the operating force needed to actuate the switch and its latency. The thinking was that a switch that requires more force might have more resistance and yield higher latency results. From our data, we can say there isn't a very strong correlation. This means that the Kale box thick clicky navy switches are perfectly suitable for gaming, so feel free to live your dream of being the worst housemate ever. But circling back to the main question, does your switch choice affect your keyboard's latency? The short answer is it depends on your keyboard. The long answer is that we use some cool math to estimate each component's contribution to the overall system, because this is ratings after all. Since we have this database of 101 switches with a breakdown of 58 linear switches, 30 tactile switches, and 13 clicky switches, we have a pretty good idea of the behavior of each switch type. We can predict the latency of any switch, even ones we haven't tested, using a model of the switch's typical behavior. Then we can subtract that predicted switch latency from the measured keyboard latency to obtain the estimated PCB latency. With both these numbers, you can see just how much each component affects the overall latency. Let's take a powerful gaming board, like the Razer Black Widow V4 75%. The total overall latency of this keyboard is 1.6 milliseconds. There's very little delay from pressing the key to the action appearing on screen. It comes with Razer Gen 3 orange tactile switches, from which we can take the keystroke data. The most important part is the 2.1 millimeter pre-travel distance and the total travel distance. Using our handy little formula here, we can plug in the pre-travel distance, total travel distance, and total latency of the keyboard. we end up with an estimated switch latency of about 1.9 milliseconds and an estimated PCB latency of negative 0.3 milliseconds. I know what you're thinking. Well, wait, how do you end up with negative PCB latency? And no, it's not time travel, it's just the margin of error. With our method, we can estimate switch latency within 0.5 milliseconds, which is pretty accurate. Generally, high-end keyboards with an 8 kHz polling rate can respond to the host's polls and update info every 1/8 of a millisecond, making their PCB latency negligible. Even comparing our method of calculating the PCB latency with the actual latency we obtained from the switch, we're very close. 1.9 milliseconds to 2.1 milliseconds isn't detectable. We use this method so we can cover more keyboards beyond the ones whose switches we've tested. But as you can see, for high-end keyboards and professional gamers where every millisecond counts, the switch you use definitely impacts your overall latency, as it contributes nearly all of the latency you may experience from your keyboard. Obviously, you should add latency from your operating system, game, GPU, display, etc., but cutting down just those 2 to 3 milliseconds at every step has the trickling effect of cutting about 15 to 25 milliseconds of latency throughout the whole system. For other keyboards that aren't designed for gaming, like the Keychron V1, the switch latency is mostly negligible. This is because its PCB latency is high enough that your switch's latency won't make all that much of a difference unless the switch itself is inconsistent. Numbers and data are one thing, but really the biggest takeaway we've learned from this development process is that the biggest impact comes from, well, the impact. As we saw before, the speed of the solenoid changes the results. Different solenoids yield different results. How you press the switch, how fast and with how much force and for how long, affects the overall latency of the switch more than any other factor. So, for that reason, we keep the same setup across every switch and every keyboard. This way, all our results are comparable, giving you a good sense of where each switch falls. At the end of the day, if I can't blame my switches, neither can you. The number one thing that introduces latency is you. But that doesn't mean you can't benefit from the latency data on 101 switches and 96 keyboards. If you're looking to competitively game and want to customize your setup to that goal, our results will help you. And if you're just a humble writer, typist, or general computer user looking for a nice keyboard with a satisfying typing experience, stay tuned to our channel for our next video where we cover our keystroke and smoothness tests. Until next time, I'm Abby from Ratings.com, where we help you find the best product for your needs. Let's take a powerful gaming board, like the Razer Black Widow V4. That's the wrong keyboard. Powerful gaming keyboard, like the Razer Black Widow V4 75%. And then the prompter will cease to work.